everybody, how's it going? This is Jason, the Science Outreach Manager and the Life Science Educator here at the Children's Museum Houston. I am here to do a live today as part of our Energize This Wonder Week, and this is being brought to you by the good people at Texas Children's Hospital, so yay for them! Thank you so much, Texas Children's Hospital. Today we are going to do something called Magic Milk. And Magic Milk is going to have us talk about fat, which we talked about on Monday's video if you watched that for Energize This Wonder Week. And we're going to talk about something called a surfactant. So let's first talk about milk. Milk is a nutrient that we drink a lot of. Milk is made up of really just three things: water, fat, and protein. Now, if you remember, there are 4 macromolecules needed for life. One of them is lipids or fat, one is carbohydrates, one is protein, and one are nucleic acids, which we have 2 of, DNA and RNA. So, when I talked about fat the other day, I am going to bring it full circle to let you know about the fat inside of whole milk. You might recall, there are different types of fat, and some we consider good, and some we consider not so good. The good fats would be like monounsaturated fats and polyunsaturated fats, the stuff that you find like in avocados and really lean fish and nuts, things like that. Then you have saturated fat, which you can have some of, but you want to have it sparingly, and you actually find saturated fat inside of milk, especially whole milk. And then you have trans fat, which you find like in fried food and whatnot, and that you don't really want to, you want to avoid that as much as you can. But the reason why I want to use this whole milk today is because the fat inside is what's going to make the milk magical. I am going to add a surfactant to this milk, and a surfactant, really easy definition, when it comes in contact with a liquid, it actually reduces the surface tension of that liquid by dissolving some of the stuff in the liquid. So what you're going to see is this milk in this plate here. I'm going to add some food coloring, and then I'm going to add a surfactant and to help you understand what's going on with the experiment. And then I'm going to challenge you to take this experiment further, because like I said, I am using one type of milk and there's a lot of other types of milk. So that is something to keep in mind. All right, so how do we do this experiment? Well, I'm going to open up the milk and I'm going to pour it inside of here. And you can see it coming in. Can everyone see this good page? You can come in closer if you want. All right. Then I'm going to take food coloring, and I'm going to put little drops of food coloring all over it, okay? So I'm going to put some red food coloring, just like a little drop here and there. I'll do the cardinal directions with the food coloring red. And I'll put some yellow, like maybe I'll put yellow in the middle and drop it. Put some yellow over here, like that. And then I got to put some green. Put the green here, and here, and here, and here, and here. And then I'll put some blue. Blue, 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 blue. All right, now I want you to go ahead and use your scientific brain right now. I'm going to take a Q-tip. And I'm going to just start to move it around the milk. And I want you to think to yourself, is anything going to happen? Am I going to swirl around the food coloring? Am I going to make a mess? What's going to happen? So I'm going to take my Q-tip right near this green drop right here, and I'm going to touch it. And you don't really see much happening. I'm going to come over here and touch the blue one slightly. Spreads it out just a little bit, and I'll try this red one. Again, just a little bit, and I'll try the yellow one. Not much happens. That's because the fat in the milk has a high amount of surface tension, so it's not able to allow the food coloring drops to move around. So what I'm going to do is I'm next going to take a clean toothpick, Q-tip. I'm going to dip it in soap right over here. This is just regular Dawn soap. And watch. You ready, Paige? I'm going to put it right over here. You ready? And you can see that it's starting to move without me even doing anything to it. Look at that. It's moving it around. And now I could take it and I can move it. I can take it and I can move it about. And I can make a pretty design with it if I want. And I can make it look like a tie-dye t-shirt. And I can do all kinds of things with it because I am now reducing the surface tension. And I can swirl it about and just make a beautiful work of art, really, if you think about it. Look at that. That's pretty cool, huh? Okay, so what happened here? It's a fun little experiment, so I'm still doing it, but I'll start to explain what's going on. Soap is a product, a substance that lowers surface tension. When I put the soap into the milk, there are two different types of molecules in the soap. There is a hydrophilic and a hydrophobic molecule. Hydrophilic means it likes water, so that part of the molecule takes water and moves it away from the fat. The hydrophobic molecule does not like the water, so it attaches itself to the fat and starts to dissolve the fat so that the food coloring, which was resting on top, starts to move around in the less tension milk. So, think about this for a moment, my young scientists. Why do we use soap to clean our dishes? It's because grease, which comes from fat, is dissolved in soap. And that's why we use it. So if you really start to think about it, this entire experiment makes sense because what I'm really doing is I'm taking this Q-tip and I am dissolving the fat and basically turning this into water, which food coloring mixes with water. So that's exactly what's going on here. Now, remember I told you I was going to have you think like a scientist? There is all kinds of different types of milk. I'd like to see you do this with other types of milk. There is whole milk, which is this right here. There's 2% milk. There's 1% milk, which means the fat is reduced to those levels. There's skim milk. There's non-fat milk. Think to yourself, would this work with non-fat milk? Probably not. You probably put the food coloring in and it will start to mix right away with the clean Q-tip, okay? But then we also have milk substitutes. We have flax milk and almond milk and all those kinds of different milks. So you can set up an experiment where you have, say, like almond milk, and you have chocolate almond milk and vanilla almond milk and 2% milk and 1% milk and skim milk and regular milk and see how it is different in each one. And then you could take a picture of it and you can put it on our social media websites. We have Facebook and Twitter and Instagram, and it's all cool for us to see what you're doing. Now, right now you're watching this on Facebook, but later on we're going to put it up on YouTube. If you watch us on YouTube, hit our subscribe button because then you will get notifications of all the stuff that we're doing, like science videos and story times, Mr. O's Oh Wow moments, the famous Mr. O, and our Tater Tots Tot Tunes. So, I am going to end this live right now and thank you all very much for joining me. I also want to thank Texas Children's Hospital for once again sponsoring this experiment. I hope you guys are all having a really good day and I hope to see you all soon. Have fun experimenting, everybody. Bye.